So today we're going over Chapter 7, Section 1. We're going to start with the warm-up. As we can see, AC is going to be greater than DF because the angle is 115, while the other angle is 110, therefore making that triangle a little bit bigger. Then for the next triangle, we have the measure of angle HGI is going to be congruent or equal to the measure of angle IGJ because those triangles are congruent by the HL theorem. Then we're going to have measure of angle 1 and measure of angle 2. Measure of angle 2 is going to be bigger because this side is bigger. And then we have the segment KL and the segment MN. The segment KL is going to be less than the segment MN, again because of the sizes of the angles. So the parts of the polygon. Each segment that forms a polygon is a side of the polygon. The common endpoint of two sides is a vertex of the polygon, and the segment that connects any two non-consecutive vertices is a diagonal. So we have the diagram label. The sides of the polygon are all of the red lines. So all of these are the sides of the polygon. The diagonal is always a line that connects at one point with the other, but it's not a side. So it means it's cutting through the figure. And then the vertex is where the two lines meet. So we have all of these vertices in blue, and we have one diagonal in green. Now we have the name of the polygons. You can name a polygon by the number of its sides, and the table shows the name of some common polygons. For 3 sides, you guys know that's a triangle. It's a triangle. Then we have a quadrilateral, could be a square or rectangle, a kite, all of those. 5, it's a pentagon. So 5 sides, 6 is a hexagon, 7 heptagon, 8 sides octagon. A very common 8-side figure that you guys see on a daily basis is a stop sign. Then you have a 9, which is a nonagon, a 10, which is a decagon, a 12, which is dodecagon, and then an n-gon is the side plus the word on. You see all of them have it. The G-O-N, G-O-N, G-O-N from 4 onwards. So now we're going to talk about sum of interior angles. To find the sum of the interior angles measures of a convex polygon, draw all possible diagonals from one vertex of the diagonal. This creates a set of triangle, and the sum of the angle measure of all triangles equals the sum of the angle measures of the polygon. So you guys remember triangles internally, they all add up to 180. So if we have one triangle, the sum of the interior angles is always going to be 180. If we have 2 triangles, it's going to be 180 and 180. If we have 3, it's going to be 180, 180, and 180. And if we have 4, again, 180, 180, 180, and 180. So if you divide all of those shapes into triangles inside of the shape, it'll make it a lot easier to figure out the sum of the interior angles, just because the triangle is always going to be constant no matter what. So guys, this is what I drew on the diagram. This is what is on the table. So for triangles, we have the interior angles is always 180. For a quadrilateral, which is going to be 2 triangles, it's going to be 180. For a pentagon, it's going to be 3 triangles, it's going to be 180 times 3. For a hexagon, it's going to be 6 sides, so it's going to be 4 triangles, so it's going to be 180 times 4, and so on. The rule of the matter is for the sides of the triangle, you subtract 2 from that, and that's how many triangles you're going to have, okay? So 3 minus 2, you get 1 triangle. 4 minus 2, you get 2 triangles. 5 minus 2, you get 3. 6 minus 2, you get 4. And that is true for all of the polygons. Now, the rule is n minus 2, which is what we have right here. That is how many sides you're going to have, how many triangles you're going to have, and that's what you're going to multiply by 180 to figure out the angle. I don't know if you notice, for a triangle with one triangle is 180 times 1. For a quadrilateral, which is 2, is 180 times 2. For a pentagon, is 3 triangles, so 180 times 3. For a hexagon, it's going to be 4 triangles, so it's going to be 180 times 4. And for the n-gon, it's going to be n minus 2, so the rule, times 180. So that's always going to be true to find the sum of the interior angles. So theorem 7.1 and corollary. So the polygon interior angle theorem is the sum of the measure of the interior angles of a convex, that is a key word, n-gon is n minus 2 times 80. So that is the rule we just went over. Then we have the corollary 7.1, which is the polygon interior angle theorem. So the sum of the measure of the interior angles of a quadrilateral is 360. Now, if you guys remember in the previous slide, we have a quadrilateral. It has two triangles. So because it has two triangles, we would end up with 180 times 2, which at the end of the day is 360. So you can use one theorem to solve for the other. This is just a rule that a quadrilateral is always going to be 360. But if you happen to forget, you can always go back to the triangles and break up a quadrilateral into two and do 180 times 2. There's always a way around it for you to be able to solve it. All right, so we have equilateral, equiangular, and regular polygons. These are kind of definitions. So for equilateral, so lateral sides, all the sides are congruent. Then you have equiangular, so all the angles are congruent. So angle sounds similar for you to be able to remember. And then we have a regular, which is all sides and angles are congruent, both equilateral and equiangular. So you guys might have an equilateral polygon, but you're not going to have an equiangular polygon. You may have an equiangular, but not equilateral. And if you have a regular, that means it's congruent no matter what. It's going to be equiangular and equilateral. We have to classify the polygon by the number of sides and tell whether the polygon is equilateral, equiangular, or regular, and explain. So let's do it by parts. Let's classify all of them by the number of sides. So this is 1, 2, 3, 4, 5, 6 sides. So because that is a 6 side, that is the hexagon. Now they want us to tell if it's equiangular, equilateral, or regular. They're telling us all the angles are congruent, and they're telling us all the sides are congruent. So this is a regular polygon. So it has equiangular and equilateral. Now we have this next one is going to be, it has 4 sides, so it's going to be a quadrilateral. And it's telling us it only has these 2 angles congruent and these 2 angles congruent. So it is going to be an equiangular in some points, it's going to be an equilateral in some points, or a regular, again, in contrast to the sides. But because it's not in the entire figure, we cannot say it's neither equiangular, equilateral, or regular. So it's none of the other ones because it's not throughout the entire polygon. Now we have for figure C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 sides, so it's a dodecagon. They're telling us all of the angles are congruent, and they're telling us all of the sides are congruent. So this is a regular polygon. All right, so now we're going to go over theorem 7.2. So this is the polygon exterior angle theorem. The sum of the measures of the exterior angle of a convex polygon, so one angle at each vertex, is 360 degrees. Again, the key word right here is convex. And in this case, we have 1, 2, 3, 4, 5 angles. And the sum of all of those angles should be 360 degrees. So guys, we're talking about the interior angles right now. So the measure of each interior angle is a regular polygon. This could be a formula. N minus 2 times 180 divided by n. Again, this is only for regular polygons. So if we have, let's say, a quadrilateral, so it's going to be 4 interior angles, we can say 4 minus 2 times 180 over 4. It's going to give us 2 times 180 over 4, which is going to simplify to 180 over 2, which ends up with 90. So that means each individual angle is 90. So this is 90, 90, 90, and 90. That is true for a regular polygon. If it's not regular, you cannot use this formula. So we're gonna go over how to find the interior angle and the exterior angle. So we're gonna assume, guys, this is a regular polygon. So we can either use this formula to figure out the addition, like how much each angle is, but they want the sum. So because they want a sum, I'm gonna actually just use the chart that we had earlier. So for a heptagon, hepta means 7. So it's gonna be 7 minus 5. So we're gonna have 5 triangles. So we can say 5 times 180, it's gonna be the sum of all of the interior angles. So if we do 180 times 5, I get that is 900 degrees. So that is how much the interior angles is, the sum of each interior angle. Now for the exterior angle, guys, as I mentioned before, they should always add up to 360. So it doesn't matter how many angles, how many sides, the exterior is going to be 360, as we saw about 2 slides ago. And then for a 17gon, it's going to be, again, for the interior, 17 minus 2. That's going to give me 15 times 180 for the sum. So 180 times 15 is going to give us 2,700 degrees. And again, for the exterior, it should be 360. They want us to find the number of sides of a convex polygon with the sum of 900. Now remember, for the interior angles, we always have n minus 2 times 180. That is for the sum of a convex interior angles. So if we have that is equal to 900, we can solve for n, and that will be the sides. So I'm going to start by dividing by 180 on both sides. So if I have 900 divided by 180, I'm going to get n minus 2 is equal to 5. I will then add 2 on both sides, and I get that the polygon has 7 sides. So because it has 7 sides, it's a heptagon. That is how you find how many sides from the sum of the interior angles. Okay, guys, so for example 4, I'm going to give you the formula that you're going to have to use to solve for each angle. All right, so we're talking about regular polygons. To remind you again, this formula is only for regular polygons. So we have a regular quadrilateral. Quad means 4. So I can do 4 minus 2 times 180 divided by 4. It's going to give me 2 times 180 divided by 4. I'm going to simplify the 2 and the 4 to get 180 over 2. So each individual angle of this regular quadrilateral is 90 degrees. Now for a regular octagon, octa means 8, so I'm going to do 8 minus 2 times 180 over 8. So it's going to simplify to 6 times 180 over 8. I'm going to simplify the 6 and the 180. So 180 times 6 is going to give me. All right, so guys, 180 times 6 is 1,080. Divided by 8, guys, that will give us that this octagon, each angle has a measure of 135 degrees. So we have a regular 15agon. So we're going to do 15 minus 2 times 180 over 15. Again, that's going to simplify to 13 times 180 over 15. And I'm going to go ahead and do 180 times 13, and that's going to give me 2,340 divided by 15. So when I divide the 2,340 by 15, we get that this regular 15agon is 156 degrees. While you guys finish copying this down, you guys do have homework tonight. This is the last slide of the lesson.